cloud longer than California streaks across Mars' ruddy cheek. It looks as though an impressionist painter loaded his palette knife with white and scraped a line across the canvas as far as the oily paint would travel. This is not what astrophysicist Jorge Hernández Bernal first saw in 2018 when the Mars Express visual monitoring camera, affectionately known by the European Space Agency as Mars webcam, posted a new picture. To the average eye, it was grainy and inscrutable, with the resolution of a standard computer camera circa 20 years ago. But Bernal, who was studying Martian meteorology at the University of the Basque Country in Spain, immediately recognized the shadow as something else. A mysterious weather phenomenon happening on the red planet. It wasn't until researchers looked at the cloud with better equipment that Mars revealed the cloud in all its sprawling glory. The team dug deeper into photo archives and discovered it had frequently been there. It was there through the aughts, and it was even there during NASA's Viking 2 mission in the 1970s. The secret had been knowing when to look for it. Bernal told Mashable there were people thinking ESA was faking it. It was a bit hard because I was really young at the time of the discovery, and I was on Twitter trying to speak to people. Bernal and his team published their observations in 2020, dubbing it the Arsimon's elongated cloud, or AMEC for short. With the cloud spanning 1,100 miles, scientists believe it could be the longest of its kind in the solar system. That work was followed with a second report, recently published in the Journal of Geophysical Research, Planets, revealing just how the volcano makes this extraordinary cloud alone in an otherwise cloudless southern Mars that time of year. For decades, the icy cloud arrived at sunrise on the western slope of Arsimon's, an extinct volcano. The once lava-spewing ancient mountain is about 270 miles wide at the base and soars 11 miles into the sky. It dwarfs Mauna Loa, the largest Earth volcano, which is about half its height. The curious case of the gigantic cloud is how it escaped notice for so long. But some of the spacecraft around Mars, such as NASA's Mars Reconnaissance Orbiter, are in orbit synchronized with the sun, meaning their cameras can't take pictures until the afternoon. By that time, the fleeting cloud, which lasts only about 3 hours in the morning, is already gone. The Mars webcam wasn't originally meant for science. Its purpose was to provide visual confirmation that ESA's Beagle 2 lander had separated from the Mars Express spacecraft in 2003. In hindsight, the space agency is glad it decided to turn the basic camera back on. Just as southern Mars experiences spring, the cloud grows and stretches, making a wispy tail like a steam locomotive over the mountain's summit. Then, in a matter of hours, the cloud completely fades away in the warm sunlight. For a young scientist working on his doctorate degree, the natural wonder became a sort of muse. While the realist in him said that recreational space travel is impractical, perhaps even unethical given the world's climate problems, he couldn't help but try to draw what the cloud might look like from the ground. I keep imagining how it would be for a little civilization to have this huge cloud every year at the same time. Like maybe the solstice is something for them like a coat, he said, smiling. This is the imagination part. So what makes this strange, stringy cloud? For starters, it's not smoke billowing from a volcanic eruption. Scientists have long known the volcanoes of the red planet are dead. Rather, it's the so-called orographic effect, the physics of air rising over a mountain or volcano. The researchers ran a high-resolution computer simulation of Arsimon's effect on the atmosphere. Strong winds whip at its foot, making gravity waves. Moist air is then temporarily squeezed and driven up the mountainside. Those drafts blow up to 45 miles an hour, forcing the temperature to plunge by more than 54 degrees Fahrenheit. This allows water to condense and freeze at about 28 miles above the volcano's peak. For about 5 to 10% of the Martian year, the atmosphere is just right to make the cloud, with the dusty sky helping moisture cling to the air. Too early in the year, and the air would be too dry. Too late in the year, and the climate would be too warm for water condensation. But though the scientists' simulation was successful in forming the cloud under Arsimon's unique conditions, it could not replicate the cloud's lengthy tail. Scientists say that's the biggest question of the moment. A mystery that could be solved with spectrometers, devices on spacecraft that identify the kinds of particles in a substance. A closer study of the cloud's water ice might give researchers more clues. Bernal said, "I would like to see this cloud with my eyes, but I know where my place is." Sometimes we think of space like a utopia. I'm happy looking at it from Earth through my spacecraft.